Hello everyone. In this video, we are going to discuss the questions of the first exercise of chapter 3, that is matrices. So this is exercise 3.1. So the first question is, in the matrix is given to us. This is the matrix. So here we can find 12 elements with 3 rows and 4 columns. So what is the first question under this? The order of the matrix we need to find out. We have to write down the order of the matrix. So very clearly, when there are three rows and 4 columns, therefore the order of the matrix will be, of course, 3 by 4. So that is what is written in the answer part. In the first answer, what do we have? The order of the matrix is 3 by 4. There are 3 rows and 4 columns in A. Therefore, order of the matrix will be number of rows by number of columns. So ultimately, the result is 3 by 4. So how many number of elements could be found there? So there is only one way out in our hand. Just multiply the number of rows by number of columns, and we shall be getting the result is 12. Therefore, total number of elements present in this matrix is 12. After that, look at the third question. What is asked here? Write the elements A13, A21, A33, A24, A23. So let us first check the position of A13. A13 represents position of the element in the first row. That means I mean to say A13. This shows the position of row. That means it is R1. And the second part shows the position of the column. So it is C3. So the element lying in the first column of the element lying in the first row and the third column will be the required position of A13. So let us find out the position of A13 in the matrix. So in the matrix, very clearly it can be found that the element lying in the first row. So in this matrix, let us check the position of A13. So this is the first row and this is the third column. So the element lying in the first row and the third column will of course be this one. So the answer is 19. So next is A21. A21. A21 stands for the second row and the first column. Second row and first column. So the term present in second row and first column is this one. So the result is 35. Similarly, A33, the element lying in the third row, third column. Third row, third column. Third row is this, third column is this. So the element present here is this A33. Similarly, you can find out the positions of A24 and A23. So the value of A24 is the value of A24. So the value of A24 is 12 and that of A23, which lies in the second row and third column, is 5 by 2. Then moving on to question number 2. What is said here? If a matrix has 24 elements, what are the possible orders it can have? What if it has 13 elements? So let us check the first part first. So it is said that the element is having 24 elements. The matrix is having, it is said that the matrix is having 24 elements. So these 24 elements, how can this be arranged? We have to arrange these elements, these number of elements, in the form of rows and columns. So when the matrix has only one row and 24 columns, then the order of the matrix will be, when the element is having one row and 24 columns, the order of the matrix will be 1 by 24. So it is said that it is having one row and 24 columns. Similarly, when the matrix is having when the matrix is having 1 row and 24 columns, the order of the matrix will be 1 by 24. Similarly, when the matrix is having 2 rows and 12 columns, 2 12 ja 24. So it can actually, this is nothing but factorization, means possible factors of 24. If you write, you will be getting these outcomes. So when there are 2 rows and 12 columns, then the order of the matrix will be 2 by 12. Similarly, when there are 3 rows and 8 columns, the order of the matrix will be 3 by 8. When there are 4 rows and 6 columns, again the product is 24 only, so 4 by 6. The reverse order if we follow, when there are 6 rows and 4 columns, then the order of the matrix will be 6 by 4. Similarly, when there are 8 rows and 3 columns, the order will be 8 by 3. Likewise, 12 by 2, 12 rows and 2 columns, then 24 rows and 1 column. So these are the possible ways we can arrange the 24 elements present in the matrix in the form of possible orders, in the form of possible orders, in the form of possible orders. If we look at the second part of this question, when the matrix is having 13 elements, then what are the possible orders? So when you factorize, only two factors we get, 1 by 13 and 13 by 1, means 1 and 13 are the factors of 13. Therefore this can be arranged in the form, 1 by 13 and 13 by 1. Question number 3 is exactly similar to question number 2. So please try this yourself. So next, coming to question number 4, what is said here, we are to construct a 2 by 2 matrix. 2 by 2 matrix means matrix with 2 rows and 2 columns. Aij, capital A equals to, within the box it is written small aij, where small aij is an arbitrary element found inside the matrix A, whose elements are given by aij equals to, this is the, let us look at the first question. So aij, what is the value of this arbitrary element? It is I plus j whole square divided by 2. We have to construct a 2 by 2 matrix. So how many positions will be there? Let us check. Suppose A is the matrix and we are to construct a 2 by 2 matrix. So it will be looking like this: A11, A12. These are the elements of the first row, and the second row elements are A21, A22. So this, actually we are to construct this matrix. Now how to evaluate the positions? It is already mentioned that in general 2 by 2 matrix is given by, this is the form of writing the matrix. So we are to get the individual positions using this expression given. So for the first value, let us look at this part first. The first value A11. For A11, both I and J will be taking values 1 and 1. So in this particular expression, in places of I and J, we shall be putting values 1 and 1. That will be resulting into, this is simplification only, 1 plus 1 whole square will be equal to 2 squared, and result is 2 here. So the first position A11 will be occupied by the value 2. After that, for A12, that means for the element lying in the first row and second column, value of I will be equal to 1 and that of J will be equal to 2. So in this particular expression, this is the expression actually we are using here. In place of I, we are putting the value, in place of I, we are putting value 1, and in place of J, we are putting the value 2. So this will be the result ultimately. So this is the value for A12. Similarly, for the element A21, the value of I is 2 and the value of J is 1. So in the respective places of I and J in this expression, we are putting 2 and 1 respectively, and reducing it, simplifying it, we are getting the value 9 by 2. Similarly, for the fourth position, that is A22, here both the values of, for both I and J, we shall be getting 2 and 2. And in the respective places of I and J in this main expression, we shall be putting 2 plus 2 whole square divided by 2, and the result is 8. Now, in the respective places of A11, A12, A21 and 22, let us put these values. Okay, so putting these values, this is the matrix we are getting. Now, for the second question, question number 4, Roman 2. The expression for Aij given here is I by j. So given here is I by j. So here again for A11 we shall be getting 1 by 1, means both in place of I and j we have to put 1 and the result is 1 here. Then A12, for A12 I mean first row second column, the element is this and the value for this will be 1 by 2, means I is taking the value 1 and j is taking the value 2. Similarly, for A21, value of I will be 2 and value of j will be 1. I hope you understood. Means I is taking the value 2 and j is taking the value 1 here, and the result is 2 ultimately. And then for A22, for A22, both I and j are taking the values 2 and 2, resulting into 2 by 2 is equal to 1. So in the respective places of A11, A12, A21, A22, let's put these values and this is the required answer. Now let's look at the third question under question number 4, Roman 3. So here we get Aij is equal to this expression, means in the numerator part we have I plus 2j whole square and in the denominator we have 2. So for A11, both I and j will be getting replaced by 1 and 1. That is what is written here. For I, the value is 1. For j, the value is 1. And the result on simplification we are getting as 9 by 2. Then for A12, in place of I we are getting the value 1 and for j it is 2. So on simplification the result is 25 by 2. So for A21 in place of I we have the value, for I we have the value 2 and for j we have the value 1. Why so? Because the position is A21. The first value, I mean for I we should get 2 and for j we should get 1. On simplifying, the result comes as 8. Similarly, for A22, in places of I and j, we have the results 2 and 2 and ultimately it can be reduced to the form 18. Reduced to the result 18. So the required matrix after putting all the respective values of A11, A12, A21 and A22, we are getting these values and this is the required answer. One thing is to be noted, please look at this highlighted part. A11, let us make it big. So A11, for A11 I is equal to 1, j is also equal to 1. For A12 I is equal to 1, j is equal to 2. For A21 it is I is equal to 2, j is equal to 1. Similarly for A22 I is equal to 2, j is equal to 2. So let us look at question number 5 next. Question number 5, here the question is a bit different. Not exactly different, actually this question is similar to last question only, question number 4 only, but the order of the matrix is different. As the order of the matrix is different, it will mean that the size, I mean the arrangement of rows and columns in the matrix will be different. So let us look at the explanation part first. For a 3 by 4 matrix, the elements of the matrix can be arranged in the following way. Now what is the way? Let us look at the first and foremost thing that we have to notice here is what? There should be 3 rows. That means R1, then this is R2, then this is R3. In here this is the first column C1, C2, C3, C4. It means what? There should be 3 rows and 4 columns. Then only this order will be satisfied. Now along the first row there we find 4 elements. As there are 4 columns, therefore for each column there will be one element each. So along the first row there are 4 elements. So since these elements are lying in the first row, so these will be taking positions A11, A12, A13, A14. Likewise, for the second row there will be of course again 4 elements. So these will be taking positions A21, A22, A23, A24. Similarly for the third row also. Now using this expression for Aij, we have to evaluate the respective positions of these matrices. I mean, there are all 12 elements in this matrix. So we have to evaluate each of the positions using this particular expression. This expression is what? Aij equals to half of modulus minus thrice I plus j. I and j will be taking different values according to the position of these elements of the matrix. So for the first value A11, both I and j will be taking values 1, 1. So when we put these values inside a modular sign, this will be the result, and when we remove the modular sign, it will come out as positive term. So after simplifying, 2 will be getting cancelled, result is 1. So looking at the rest of the looking at the rest of the elements A to 1, here in this case value of I will be 2, value of j will be 1. On simplification we get this value. Similarly A31, so in place of I we are getting 3, in place of j it is 1. On simplification we are getting value 4. Then similarly for A12, actually we are finding out the values column wise. So this is up to here. The first column elements we are finding out. Again starting from here, the second column elements we are trying to find out. So respective positions are A12, then A22, A32. In places of I and j, the respective values we are putting, and on simplification these results we are getting. So all these are simplifications only for the respective positions. These 3 will be for third column, and these 3 will be for the fourth column, and the respective values of I and j are put in the expression given. On simplification these are the results we are getting. So in the respective places of A11, A12, A13, A14, I mean the first row elements, second row elements, and the third row elements, we are putting the values, and on putting the respective values from this part, the result we get as this matrix. The third sum is also of the same kind, so all of you please try yourself. Next, coming to condition of equality of two matrices. I mean condition of equality of matrices. So two matrices capital A and capital B with arbitrary elements Aij and Bij respectively, and they are of order respectively of orders respectively m by n and p by q. These two matrices are said to be equal if the number of rows in A is equal to the number of rows in B. That means whatever number of rows the matrix A is having, the same number of rows should be present in the matrix B also. At the same time, looking at the second question, looking at the second point, the number of columns of A, matrix A, should again be equal to number of columns of matrix B. That means n is equal to q. I mean matrix A is of order m by n, and matrix B is of order p by q. We want that these two matrices should be equal. To satisfy equality of these two matrices, first of all, the conditions to be fulfilled are, in case of M and P, there should be equality, and in place of n and q there should also be equality. That means number of rows of the first matrix should be equal to number of rows of the second matrix. At the same time, number of columns of the first matrix should be equal to number of columns of the second matrix. After that, the next important point is the corresponding elements, values of the corresponding elements of these two matrices should be equal. That means in point form, while giving you the information, we are using the term Aij. We are using the term Aij is equal to Bij. Actually, this equality is valid for all values of I and j lying in between. Means when value of I lies in between 1 and m and value of j lies in between 1 and n. Okay. So illustration part, let us look at the illustration part. Suppose A is having elements A11, A12, A21, A22, and matrix B is having elements B11, B12, B21 and B22. When these two matrices are equal, actually these two matrices to be equal, the second condition to be fulfilled is what? The corresponding elements should be equal. When we try to find out the corresponding elements, this element and this element means first row, first column elements are corresponding. Similarly, this and these elements are corresponding. Similarly, this and this, at the same time this and this. Now let us look at the illustration part. For the first 2 points, two matrices, we are considering A and B. These are the elements. Then matrix B is having these elements. So for these two matrices to be equal, they must have the same order. That means we can observe here that matrix A is of order 2 by 3. Am I right? And matrix B is of order 2 by 3. So both these two things are of the same order. Therefore, these two matrices can be equal. I mean, the first two conditions are satisfied here. So order of both A and B are same. Therefore, the first two conditions are satisfied. After that, what is said here, for the equality of two matrices A and B, their corresponding elements should be equal. That means Aij equals to Bij when value of I starts with 1 and ends with m, and Aij equals to Bij, and for this Aij equals to Bij, and for this I is equal to 1 and 2, of course, and j is equal to 1 and 2 again, 1, 2 and 3, and j is equal to 1, 2 and 3. Actually, I refers to the number of rows and j refers to the number of columns. So I can take the values 1 and 2 and j can take the values 1, 2 and 3. So this means what? The corresponding elements should be equal. That means A11 equals to B11. That means in the previous example, what example was said in the illustration part, A is equal to P. After that, B is equal to Q, C is equal to R. Similarly, X is equal to 1, Y is equal to 2 and Z is equal to 3. That means the corresponding elements of both the elements should be, corresponding elements of both the matrices should be equal. So this is condition of equality of two matrices. So these are the conditions of equality of two matrices. In the next video, we shall start with question number 6 of this exercise. Thank you.